In this video, I'm going to be covering how to solve the integral of sine to any power. So questions that look like this. There are three identities that are important to know. The first one is the integral of sine. The second one is an identity that you'll use when solving integrals of sine to an odd power. And the last one is an identity that you will use when solving sine to an even power. Let's start off by solving the integral of sine squared x. Since this has an even power, we'll use the third identity I just showed, so the power reduction identity. And we'll write this as 1 minus cosine 2x over 2. Now we can rewrite this again, but bring the 1/2 as a coefficient out in front. So that's 1 minus cosine 2x dx. So this will now become 1/2. The integral of 1 is just x. The integral of -2 cosine x, since this has a 2 here, that's a simple u sub that we can just do 1/2 sine of 2x. And now we just multiply our 1/2. So the answer to this integral is 1/2 x minus 1/4 sine of 2x plus c. Now let's look at the integral of sine cubed theta. Has an odd power. So we're going to start by rewriting this as the integral of sine squared x times sine x. Now we can use our trig identities to convert sine squared to 1 minus cosine squared x. And the reason we're going to do this is so that we can now perform a u sub, where we set u equal to cosine of x, and du will become negative sine x dx. So now our du will get rid of this part here, and we're just left with a negative out in front. So it's become negative integral of 1 minus u squared du, and now we can just use power rule. So this is negative u minus u cubed over 3. And all we have left to do is distribute our negative sign and substitute back in for u. So this will become negative u, which is negative cosine of x, plus cosine cubed x over 3 plus c. And that is how you solve sine cubed integral. So now we're going to solve the integral of sine to the 4th x. Since this has an even power, we're going to be using our power reduction identity. Now let's start by rewriting this as sine squared x squared dx. So this is the same thing as sine to the 4th x. Now we can use our power reduction identity. So this will become the integral of 1 minus cosine 2x over 2, which is sine squared x. But now we need to square that entire term. And then we add our dx. Now to square this, the denominator will just become a coefficient of 1/4 times the integral of, now we need to FOIL out the numerator. So this will become 1 minus 2 cosine 2x plus cosine squared of 2x. And so again, I just FOILed the numerator. Now we can start by taking the integral of 1 is just x times our 1/4. This integral here will become negative sine 2x, but we have a 1/4 in front, so that's 1/4 sine of 2x, plus, and now we have 1/4 integral of cosine squared 2x dx. Solving this integral is very similar to solving sine squared of x. Again, we have to use a power reduction identity, except this time for cosine. So the identity that we're going to use is cosine squared x equals 1 plus cosine 2x over 2. Very similar to sine, just here it's a plus. But keep in mind, here we don't have just an x, we have a 2x. And so plugging 2x into here, we can determine that cosine squared of 2x is equal to 1 plus cosine of 4x over 2. And so I'm going to go ahead and move this 2 and multiply it by the 1/4 out in front. So let's go ahead and rewrite this as 1/4 x minus 1/4 sine 2x plus 1/8 integral of 1 plus cosine 4x dx. So from here, the integral of 1 will just be x. So let's go ahead and rewrite again everything that we have. And that was 1/8 times x. And when we do a u sub with cosine of 4x, we're going to be dividing by 4. With the 1/8 coefficient, that'll be plus 1 over 32 sine of 4x. And all we have left to do is combine some of our like terms here. So now we are going to be left with 3/8 x minus 1/4 sine of 2x plus 1/32 sine of 4x plus c. And that is how you would integrate sine to the 4th of x. Alright, so the last thing I'm going to talk about is how we can expand this to solve the integral of sine to any power. So like I was saying before, anytime we have an odd power, and just for an example I'll use sine to the 5th of x, we can split it using our 1 minus cosine squared identity. So in this case it'd be 1 minus cosine squared x, that's sine squared. So sine to the 4th would be if we squared that whole term, and we have a sine x left over. And now we could u sub for cosine the same way we did for sine to the cubed of x. And if we had sine to the 6th of x, we could use our power reduction identity, except this time instead of squaring it like we did for the 4th, we'll cube it for the 6th. And you can keep following this pattern in order to solve sine to any power.